I'm gonna call it SynthDef documents. So the SynthDef is a unit generator graph that tells to the server how to make the connections to each unit generator. So to create one, we're using something which is named after the same concept. And in there, the first thing that is actually asking us is the name. So the name can be anything you would like, anything that would make sense. I tend to give names to my SynthDefs according to what kind of sound they create, right? So then immediately when I see it, I can say, I can understand what this SynthDef is actually doing in terms of sound. So the name, it has to be a symbol. A symbol is a unique name, right? So through that symbol, then we will be able to access that SynthDef. That's the reason behind of why we assign a symbol as a name of SynthDef. So I'm just going to create one which is called signs. The second thing is that I need to create a function that contains my unit generators. And that's the flesh of my SynthDef. That's the whole SynthDef unit generator graph there. That's why I said UGen graph func. So as we know, inside the function, we can have arguments. So inside arguments, so as arguments, we can create our parameters. So let's say I'm going to have, because I'm going to create sine tones. Something that sine tones, of course, they have is frequency. So I'm going to start with the default value as a float number, 120. And I can also have an amplitude. And I'm going to have something like 0.5, just for safety reasons. Now I am actually creating the connections, the bits that my node will be carrying. So I said I want to use a sine, so I need to use sine oscillators. And for that, I will use a variable first to have as out. And I can also have something like what else? I'll find out. So my frequency will have the parameter frec. As a phase, I will just use the same phase, and as a mul, I will have amp. Which amp? The parameter I have created here. Which frequency? The parameter I have created here. So that's the frec from here, and that's the amp from here. If I don't have those, then I won't be able to control anything. Now, one thing I need to create in my SynthDef in order to hear that is I need to give it an output. The output can be created by using this class called out. And then it says, I want to have a bus. The bus, as we know, is in which bus channel we are routing our node, our SynthDef later. So the bus will be either 0 or 1. But assuming I want to change the routing, I can create another argument and call it out and have an index number 0. So assuming I have already an argument called out, I can't have a variable called out, so I have to change that. So I'm gonna say signal. So the first argument of my out is the bus. The bus I just created here. I'm gonna have out, and then I'm gonna have the channels that I want to route through my channel output, and that would be the signal I have just created here. And that's that. So this is a local variable. And local variable would only be accessible inside the scope, inside the function of my SynthDef. That means that even if I create another SynthDef and name it exactly the same way, like here, as long as those are local variables, there won't be any conflict between them. So we are safe. And actually, you can use this as a template of when creating SynthDefs. You can say always, you can create a habit of your workflow that you're always gonna do things like in the same way. The only difference will be that you have different unit generators that create different sound. So in order to send this SynthDef to my server, I need to use this method called add. That's a very important method. Otherwise, if I execute this line, I have already a problem, and the problem is something that says it's in line 2. In line 2, it says, I don't like this for some reason. Now I am okay. And I have a SynthDef. So let's run it again. I have a SynthDef. This is confirmed by the post window, but I don't have a SynthDef on the server, so I won't be able to play one of its instance. So what I need to do is to add it on the server. That's something you need to remember. You could actually play that immediately. And actually, I have a single output of my SynthDef. And you see also in my node tree that I have created the new SynthDef, a new synth called Signs here, right? And you also see that I have 2 synths. If I kill that command period, you see I have 1 synth. This is a little bit confusing, but actually this 1 synth here, although I have killed everything, it still persists. And that's because I have this open. So if I stop that, if I kill that, then I have 0 synths. But assuming this is something useful, I will have it always here. So I can live with that, actually. It's not a big problem that I have something as is running 1 synth here. So I want to add it on the server instead of creating immediately a sound from it. And for that, I need to use this method called add, and goes at the end of my SynthDef. So I create the SynthDef, and then I say to it, add. So basically, to make it a little bit simpler, what is happening is I have some code here. I have a name of SynthDef here, but then I need to send that to my server and to add it on my server. So I need to use this add. So I'm just making this line to make it a little bit more cleaner of what's going on here, because this is important. If you don't do that, then we won't be able to do an instance of it. So what is an instance of it? An instance of that is that if I want to create a child of it, which is instantiating the SynthDef signs, I will ask using this class called Synth, and copying the name from here and adding here, which And now I will create an instance, a child of the SynthDef. It's different from playing it, is actually asking from the server to create, let's say, a clone of my SynthDef, a clone, an instance, a child, however you want to call it. So once I create that, I see in my node tree that I have a child of my SynthDef called science. That's very handy actually, because I could, for example, create many of that. So you can see now, like for example, I'm gonna create 4 of this. And you can see immediately that I have 4 instances of the same of my SynthDef called science, right? The same thing could be written 4.do. You remember do? It's the same thing. Again, 4. So I hope that explains why using SynthDefs it's better. And one thing you need to remember is that when you create a unit generator graph, which is a SynthDef, you have to create some parameters so you can interact with it on the fly while it runs, right? So that means I could, let's see what's happening in my meter. Of course, this is clipped, and maybe I should create this by 4, so it will be, yeah. So now the sound goes a little bit down. According to how many it is, it will create more nominal output. Now, the idea here is that I'm creating 4 of the same SynthDef by creating 4 synths. That means that I have all of my 4 voices, let's say those are voices, all of my voices going to channel 0, which is my left channel on my computer motherboard output configuration. So in order to be able to change that while this is running, assuming I have already declared an argument called out, I can change that. So let's stop that. In order to change that, the way to change that using the synth class, you see here it's args. First is the def name, which SynthDef I want, the def name, and then the args. But these have to be encapsulated inside an array. So for which argument I want to change? Out. So let's say I'm gonna route everything through my right channel, which is the channel 1, because we said it's left is 0, 1 is right. And if assuming I have only 2, that will be left right. So it's 0, 1, 0, 1, 0, 1. And you can see that now all of the voices are routed to my right channel, to the second channel of my outputs. And that is my right channel. The same could be with everything I have declared as an argument, right? And the method here is first using the symbol, which is a unique name, which comes from inside my SynthDef, declaring it, and then separating them by comma and assigning the value. it will create random numbers between 120 and 220. So how many nodes I have? I have as many nodes I have executed this line. And because this line executes 2 at one time, then every time I execute this line, it will add 2 more voices. And that creates already an interesting complex texture just by summing up sine oscillators with random frequency parameter. So I would urge you to actually do that.